Okay, so today we are going to discuss some more problems over Newton's law. And in this first question is that there is a block which is placed over a smooth surface. Its mass is m and this is 0. A force is acting over it, F, which is at an angle 60 degree from horizontal. So what procedure we will have to maintain is that now we are going to resolving this force into its component. So when we resolve this force into its component, so the component of this force in horizontal direction will be F cos 60 degree, and the component in this direction vertically downward will be F sin 60 degree. One force is already acting vertically downward, which is its weight, and other force is normal. So what is happening is that if we draw again this block, so mg is acting vertically downward and this force is also acting vertically downward, and which is F sine 60 degree. In upward direction there is normal reaction, and if we plot this force which is acting in horizontal direction, F cos 60. So what is happening is that in this direction force is acting F cos 60. Now since this block is not moving in vertical direction, this block acceleration along y-axis is 0. So of course summation of forces along y-axis will also 0. So only effective and dominating force on this block is in horizontal direction, and which is F cos 60. So F cos 60 is equal to mass times acceleration. Okay, if F will be given, suppose F is 10 Newton and M is 2 kg, we can easily find out acceleration. Sometimes it might be asked to us to find out normal reaction, so we will just equate upward force is equal to sum of downward force mg plus F sine 60, and we will put the value of F here and mass at this place, and we will easily find out what normal reaction. So this was the one type of question. Now I am going to discuss some different question. And second type of question is like this. Question based on inclined plane. Question based on inclined plane. So there is an inclined plane. Suppose this is an inclined plane and this is fixed on the surface. Right now I have taken it as a fixed, but gradually I will discuss a question in which it will be allowed to move plane 2. Now a pulley is attached on the top and a block is attached through the pulley, and its mass is m1, and second block is hanged whose mass is m2. And now you would be asked, this is angle theta. Now you will be asked to find out acceleration and tension in string and acceleration of block. So what steps we will follow? First and foremost, we will draw free body diagram. And when we will draw free body diagram, what will happen is that free body diagram of M2. So what is happening with M2? M2G is acting vertically downward. Tension is acting vertically upward at this point. I had already told to all of you in previous lecture that for a given string, which is an ideal, which is passing over a smooth pulley, tension in a given string will remain same. It's all right. The direction of tension will always be away from point of attachment. This is first point of attachment. That's why the tension is vertically upward. And for this point of attachment, tension will be downward. But we have to bear in mind, tension will remain same. So here tension is T and here tension is T. So FBD of M2 is, this is M2. M2G is acting vertically downward and tension is acting upward. Okay. As far as free body diagram of M1 is concerned, FBD of M1 is concerned. So firstly, this is an inclined plane. This is mass M1. Of course, weight is acting vertically downward. M1G. This is angle theta. So, and this is direction, normal direction. So angle between two lines is exactly the angle between lines which is perpendicular over those two lines. So this line is perpendicular over this. This I am telling you line 1 and this I am telling you line 2. So angle between line 1 and line 2 is theta. So this is perpendicular over line 1 and this is perpendicular over line 2. So this will also become theta. So its component, as far as its component is concerned, so its component along this direction will be M1G cos theta, and the component of this force M1G along the inclined plane will be M1G sin theta. Now, what is important is that since body is not accelerating, if we selected this as our x-axis and this as our y-axis, so what we are observing is that acceleration along y-axis is 0. That's why summation of force along y-axis will be 0. And along y-axis we have taken it normal reaction. This is normal reaction and this is M1G cos theta. That is n will be equal to M1G cos theta. Okay. M1G sin theta is the component of weight along the inclined plane and one extra force which is tension which is acting up the inclined plane. So this is T. So now the question is that in which direction mass will accelerate. This will be completely over our choice. P can select any direction of acceleration as per our choice. So suppose we have selected acceleration in this direction vertically downward. So if M2 will accelerate vertically downward, of course common sense suggests that M1 will go upward with the same acceleration. So now I am going to writing dynamic equation. So what dynamic equation will be for M2? M2G minus T is equal to M2 into A. This is first. M2G minus T is equal to, and for M1, T minus M1G sin theta is equal to M1 into. So this is relation. This is two equations in T and A. So of course we can easily find out tension and acceleration. Okay. Now next question. Next question is, suppose there is an inclined plane wedge. This is wedge. This is angle theta1 and this is angle theta2. It is placed over a horizontal surface, a smooth horizontal surface. So we have taken mu is equal to 0. A block having mass m1 is placed on the inclined surface of the wedge, and second mass is attached with a string whose mass of second block is m2. Now you might be asked to find out tension and acceleration of blocks. So the simple procedure we always opt is, first and foremost we have to write free body diagram. So of course this is direction of normal, this is n1, this is the direction of m1g, and its component in this direction is m1g cos theta, and its component in this direction is m1g sin theta. Now we have taken T in the tension in the string, and I know that for a given string, if it is ideal and passing over a smooth ideal pulley, then tension in a given string will remain same. Again, we are drawing forces acting over M2. So of course, weight will act in vertically downward, and this is M2G. Its component in this direction will be M2G cos theta 2, and its component in this direction will be M2G sin theta 2. Okay. Now we have assumed acceleration in this direction. We don't know about their masses. We can select any direction for acceleration, and after solving, if we get positive acceleration, that means our guess was perfect. If we get negative acceleration numerically, that means magnitude of acceleration is exactly same, but reality is just opposite what I had guessed. Now we are writing dynamic equation. So dynamic equations for M2. So this is M2G sin theta 2 minus T is equal to M2 times A. This is first, and for M1, T minus M1G sin theta 1 is equal to M1 times A. This is equation 2. Theta 1 and theta 2 will be given. M1, M2 will also be given. So these are two equations in tension and acceleration. So we can easily find out both. Now next question is, next type of question, question number 4. Suppose this is inclined plane. This is 60 degree. This is mass M1. This is mass M2 and a force. Now as we have taken this mass M3 and a force F is acting up the inclined plane. Now we have to find out tension and acceleration of the block. Firstly, we will have to understand how many strings are there. So there are two strings. So here we have taken T1. So of course for a given string, tension will remain same. And in this string we have selected tension T2. Main thing to dealing Newton's law is free body diagram. You will have to be good understanding about the forces which are acting on the body. So now I am going to write free body diagram of M3. So what is happening with M3? This is M3, this is F, this is T1, and the component of its weight. The component of its weight, this is weight M3G, along the inclined plane, the component of its weight along the inclined plane will be M3G sine theta, and which will be directed. This is M3G sine, here's theta is 60 degree. So one force F is acting up the inclined plane, and two forces T1 and M3G sine 60 degree is acting on M3 down the inclined plane. And we have assumed that it is accelerating upwards. So what equation will go? Equation will go F minus T1 minus M3G sine 60 degree is equal to M3 times A. Now, free body diagram of M2. So what is happening with M2? This is M2, right? And in this direction, tension T1 is acting. In this direction, tension T2 is acting. In this direction, component of its weight, M2G sine 60 degree is acting. And we have assumed that it is accelerating upwards. So equation will go T1 minus T2 minus M2G sine 60 degree is equal to M2 times A. This is equation number 2. Now, free body diagram of M1. So, free body diagram of M1. So, this is M1. Force upward ejecting T2, downward ejecting the component of its weight along the inclined plane, and which is M1G sine 60 degree. And since this is accelerating, all bodies are connected, so all will accelerate with same acceleration A, as we have assumed. So this is accelerating with A. So what equation will go? T2 minus M1G sine 60 degree. This is equal to M1 into A. So these are basic method to write free body diagram. Now, I am also going to discuss some more question. Fifth question. Fifth question is, suppose three blocks are connected. This is M1, this is M2, and this is M3. A force F1 is acting at an angle alpha, and a force F2 which is acting at an angle beta. And you might be asked to find out the acceleration. So how many strings are there? Two strings. So we have taken tension T1 in this string. So this is same string, so tension will remain same for a given string, but this is string, next string, other string. So in this tension will be T2, but for in this string tension will remain same, and tension is always away from point of attachment. Now, free body diagram. Since there is no movement along vertical direction, we have selected it as x-axis and this y-axis. There is no motion along y-axis. That means summation of Fy is equal to 0. That is Ay is equal to 0 for all bodies. So don't bother for vertical motion. Now we have to think about its horizontal motion. Now I am going to write the free body diagram of each block. So firstly, I am going to write free body diagram for M3. So this is M3. Of course, wet will act. Of course, normal reaction will act. And the component of this force along this direction will be F1 cos alpha, and the component of force in vertical direction will be F1 sin alpha. So this is normal reaction N3, and one more F1 sin alpha. Since acceleration along y-axis is 0, that means this sum of these two forces is equal to this F1 sin alpha plus N3. This is equal to M3 times G. Okay. Now, forces along horizontal direction. So this is F1 cos alpha. This is F1 cos alpha. And in left side, force is T1. So these are forces which we have to take under consideration, because motion might take place along horizontal directions. There is no possibility of any motion along vertical direction, as we have taken the case in which body is not moving in vertical direction. So now, since we have assumed its acceleration to the right, it is completely upon our choice. So what equation will go? F1 cos alpha minus T1 is equal to M3 times A. This is equation first. Now, FVD of M2. So this is M2. M2G is acting vertically downward. So we have normally action vertically upward. In this direction T1, and in left direction T2. And we have assumed it is accelerating with acceleration A to the right. So equation will go T1 minus T2 is equal to M2 times A. Now, FVD of M1. What is happening with M1? This force T2 is acting to the right. Of course, its weight will act vertically downward, and a normal reaction will act this direction. Now, a force F2 is acting at an angle beta. Now we are going to resolve these forces. So component of F2 in this direction will be F2 cos beta, and in vertical direction will be F2 sin beta. Since we have selected the case in which all three bodies have not escaping the surface, is not escaping the surface, in fact, no, not even a single place normal reaction 0. That means the whole movement of the body is taking place along horizontal direction. So of course, as far as vertical direction is concerned, so these two forces which is acting vertically upward must be equal to with M2G. So F2 sin beta plus normal reaction N1, this is equal to M2G. So this is the way how to think and how we have to take a step. Now, since we have selected that this body is also accelerating with an acceleration to the right, so now we are going to write down summation Fx is equal to mass x. Okay, so now summation Fx, so this is T2 minus F2 cos beta, and this is equal to M1 times A. This is equation number 3. This was equation number 2. So we can easily find out different accelerations, different tension and acceleration. Okay. Okay, now thank you so much to all of you. Now I am going to wind it up. Okay.